Hello everybody and welcome to today's webinar, Electrical Power Systems Engineering. I can see we're just getting everybody registering, so I'll just give everybody a couple of minutes to get sorted, settled in, and then we can go through an agenda of what you can expect from today's event. So just to let you know as well, we do have a Q&A session at the end of the event, so if you've got any questions which you'd like to put to our panel today, you can just use the Q&A function on the webinar and I'll pick those questions up. We do appreciate not everybody can join us for the event today, so if you are watching back again, but there is any questions you have in regards to any content covered today in the webinar, please just email studyonline@manchester.ac.uk and I'll be able to put those questions as said to our team. Okay, great. Looks like everyone's settling in nicely. Right, okay. So as I said, thank you for joining us. Today we're going to be looking at our Electrical Power Systems Engineering course at the University of Manchester, with a specific cover on the sort of Spark Future Change, looking at challenges within the industry and the role of academia. We've put a little bit of an agenda together as well, just so you know what to expect. So I'll give some brief introductions. We'll cover why study at the University of Manchester and online learning as well. And then I'll hand over to our panel today. So we have Dr. James Brooks, the academic director of the course, and we've also got a guest speaker as well, Colin Stelfox, but I'll leave them to introduce themselves in just a moment. As I said, we will be covering the course structure and units. And as I said, we will have that all-important Q&A session at the end of the event as well. So firstly, why Manchester? So as you can see, we are a leading research intensive university with 83% of our research which is ranked as world leading or internationally excellent. We're always appearing in the sort of top rankings with the university list as well. So I think it's about the 5th at the minute within the UK and 23rd best in the world, which is absolutely fantastic. And we've recently had a new ranking as well, which we're extremely proud of, and we've been ranked first in the world for social and environmental impact to achieve the United Nations Sustainable Development Goals, which has only just recently been announced, but as a university we're extremely proud of that. And just as well, our online community really is thriving. We've put a lot of investment recently within online and blended learning, so if you are considering studying with us, now is really a fantastic time to join. Aside from you know, the amazing sort of points I've just gone through, we were also established in 1824, so the university has been going for quite some time as well. Online learning, again, you know, we do appreciate it can be quite daunting going back to studying, which is why the course is really built around flexibility. You know, you really do plan to study at your own time and your own pace, place and pace as well. And there's no such thing really anymore as a typical online learning student. You know, the form of study that we have suits people with varied circumstances. You know, most of our students are working professionals, so it's very important that the flexibility of the course really suits you and works around other commitments that you have as well. Again, you know, studying online does not mean you are studying alone. There's lots of opportunities to interact with course peers and arrange individual consultations with our academic team. So studying online really has changed over the years, so you're not just sort of sat at a computer working around your own. There's lots of opportunity for your interaction as well. Okay, wonderful. So that's all I'm going to do today. So I'm going to hand over to, as I said, our academic course director, James Brooks.
Thanks, Lisa. And yeah, thank you everyone for watching this. So as the academic course director, I have a sort of an overview of the course and the academic side of what you get taught, although there's quite a large team that goes into inputting onto what gets taught and how that gets taught. But a bit about me. Back when I did my PhD, I was looking into what are the risks associated in future potential power systems that have a lot of this thing called wind power? Turns out we now have systems that are increasingly getting to those points that I started talking about in my PhD. But now I'm much more focused on the education and teaching side of university. So I'm trying to improve the quality of education, not just within this course, but actually across all programs within science and engineering. And this is the course that sort of I help build and I now look after as my main thing. So hopefully that comes through in the way the course is put together and the way you're taught. And my sort of proper title is Senior Lecturer in Electrical Engineering. And that's me. I think I will hand over next to Colin to give a brief introduction of himself. And Colin, if you just unmute yourself and give an introduction.
Okay. My name's Colin Stelfox. I work for National Grid in the electricity system operator role. I'm a fellow of the IET. I've been a chartered engineer for a number of years and a chartered manager as well. So I've been asked to talk about how the course helps at National Grid. I think we're going to go on to the detail of that a bit later, but my industry experience, I'm afraid I've been working in the industry for over 40 years now. So I started at a time when it was still publicly owned. So obviously I've seen quite a lot of change, but probably the most I've seen in the last sort of 5 or 10 years. So that's quite an interesting subject in itself. So I'll hand you back to James now.
Thanks, Colin. So I wanted to talk about how I see what electrical power systems is by sort of cutting away the things it isn't. And maybe that gives you a clearer view of where we see the course. So, you know, you can take electrical engineering and cut out all of the low power stuff, the electronics, and you get to the generation, transportation and distribution of power. We actually have a separate course in the university that's on the machines and drives and power electronics, the designing the things that generate the electricity. We don't focus on that. What we look at is this systems view. You've got somewhere that generates electricity, you need to get it to a particular place in a safe, secure manner, and you're going to have those assets there for potentially 40 years plus and need to be able to monitor, maintain them and protect them over that period. So that's really what we were trying to look into in this course. What are the components? How do you operate them? How do you get that system level view so that when there are new changes, new trends, you're in a really good position to understand those and understand the impact on the system as a whole. And this was something I found rather fascinating. So this was a view of the changes in investment in the sector, in the power sector, over the period 2015 to 2018. And the first thing that jumped out to me is these changes are in the tens of billions of dollars. They're a huge amount of money being invested in this sector and huge changes. So it was interesting to see, you know, China in the period before this invested very heavily in fossil fuels, particularly coal plants, because their industry was expanding so rapidly. And now they've jumped to trying to invest in the networks, as of the US for a slightly different reason, because of I think because of the complexity of, well, now you've just installed an incredible amount, in China's case, of new power generation that's quite far away from demand. Or in the US case, the system is becoming a lot more complex with non-dispatchable generation or non-synchronous generation, and trying to invest in those networks to say, okay, now we've got this, how do we keep the system running? And it'd be interesting to hear later, maybe Colin talk a little bit towards that. And I think part of the reason that those changes are so great is that renewable power's got a lot cheaper. So if you look at the curves on the right, this is sort of saying what's the change in the cost of installing new power plants. And if you look at coal, nuclear, gas and hydro, your traditional plants, they basically haven't changed in price from 2010 to 2018. Whereas if we pick onshore wind, that's 20% cheaper than it was in 2010. And if you look at solar photovoltaics, solar panels, well, that's almost 80% cheaper. That's an incredible reduction in price. And obviously that's causing huge changes throughout the industry. If you've got a lot of those plants, the system has to be looked at quite differently when you can't tell your generation, give me this amount of power at this time. So yeah, and that's why I sort of thinking around the research that we were doing and the research within the area. I split it into three different parts. Around generation, the generation is a lot more distributed than it was. There's a lot of smaller generators, more spread out. A lot of it's non-synchronous, giving issues around reduced inertia, and non-schedulable, non-dispatchable. You can't tell it when to generate. So there's a whole chunk of work that goes into thinking about systems with that. On the demand side, I say an increasing demand, although that varies a lot in different countries. Some areas are seeing a reduction in demand or a change in the types of demand or the times of demand. There's a lot more storage. In general, there's a lot more participation at lower power consumption levels. So there's a lot more players getting involved in the system. There's a lot more electric transport, so electric vehicles, electric rail, and rural electrification globally. And that's sort of moving, I guess, things that would be fairly normal at a transmission system down into, well, we're now looking at a distribution network and having to incorporate some of those things that we hadn't had before. So at a system level, a lot more information, a lot more control and options available to you. Maybe that means increased cybersecurity risk. Maybe that means there needs to be a lot more intelligence and automation to manage this. So that's quite a lot of things and quite a lot of changes coming that I saw from the areas people are researching and looking into. But it'd be interesting, Colin, to hear what you think around whether that's true in your part of the network and your part of the world. Yeah.
Lovely.
And there's a quote from one of our recent graduates sort of saying a similar thing. The industry used to be relatively static and now it's changing rather quickly. And I don't know whether you think the same.
Yes, I do indeed. Yeah, it's certainly a lot changed over the last 5 years or so. Absolutely.
Yeah, I think there's quite a lot going on. Yeah.
Well, we could now maybe, Colin, if it's okay with you, if you'd like to sort of provide us with a perspective. As I said, I know obviously, you said you're an advocate of academia and the importance it plays. If you could please provide us with some perspective from an employee perspective, but also from an employer perspective as well.
Yeah, what I'll talk about from my personal perspective first. When I studied for an MSc, it gave me the opportunity to refresh my qualifications. As I said, I've been in the industry a long time. So my qualifications were quite outdated. For people coming into the industry with the relevant experience, it's a way of improving and getting more in-depth knowledge, which is crucially important because the landscape of the electricity system is changing so much. The beauty of distance learning and this course like the MSc that Manchester provide is it allows you to carry on working, but also to do the education as well, because the two go hand in hand. It's really important to get the technical skills, but also understanding practically how you deploy them is also obviously very important. So when we've got employees who are studying for the MSc, they're also working full-time. So it gives you that advantage whereby if you were going full-time, I mean, there's lots of advantage to doing the courses full-time, but you do lose out on that sort of hands-on experience that you're getting in industry. And that's where the Manchester MSc really pays benefits from an employer's perspective, because you're helping them develop, and at the same time they're also learning the practical skills, and that's the beauty of the course, really. That's where it really fits in well from the industry's perspective. And you need that in-depth knowledge. You mentioned about the changes in generation patterns, much more embedded generation. So some of the sort of certainties have changed, and having the technical skill and knowledge to actually understand those changes and deal with them is what's critical when it comes along to operating a power system. And that again is the beauty of this course. I don't know if there's anything else you'd like to talk about, James. That's kind of where it fits in for me.
James, how about from an academic perspective, when you're working with students, when they're, you know, for example, students on the MSc, are they coming to you with sort of a problem in the workplace to say, you know, what can I take from the course to put into that? Or do you find it all links quite nicely with, for example, the dissertation? I know that's quite a key part of the MSc, and how that's adapted then in the workplace.
Yeah, well, I can answer that in sort of a broader terms. So actually, I'll answer it with an example from someone not from National Grid who's just said, look, I've been given an issue to explore within my company. We think we need I think they were thinking there's a particular dynamic interface. There's some harmonics caused by the connections that they've got on a particular project, and they want that explored. Now, that's a project they have to do in their role anyway. They were then saying, well, I'm coming up to the time where I'm doing my dissertation. Can I piece the two together? Can I do a dissertation that involves building up a dynamic model of this actual system that I'm working on, so that I can explore this in a lot more depth? And they'll probably explore it in more depth than they would have anyway. And this is what we're trying to get with a lot of people who come through this course. Once they've done the talk component, how can they find a research topic for their final dissertation that benefits their own learning and their own grade, but also benefits the company and the wider industry? I think it's a nice linking between industry and academia. Yes,
and certainly in the students who are at National Grid, we encourage them to for their dissertation to look at subjects they're working on themselves, or certainly other aligned departments are working on, because it's a much more richer source of material for your dissertation, and each supports the other, really. You know, they look at it maybe with a more academic lens than perhaps we do, because we're looking for an operational solution all the time, and that's useful. And that sort of approach also can draw out other issues which we might not necessarily be aware of, but that academic approach is quite important in terms of how you think about problems and how you deal with them, which you don't necessarily get from somebody who hasn't been down a route of studying at this level. So yeah, it's helpful in that way as well.
Yeah, we've certainly had, you know, we've had someone who works in a substation saying, well, you know, they know that a change that's coming is kind of the change towards digital substations. That's ended up being their dissertation topic. We've had someone who works as a protection engineer saying, well, look, I think the way that we traditionally managed our systems doesn't take into account the amount of distributed energy resources. We've had people looking into how can we model HVDC connections in an area that hasn't had it before, that they're having to look at in their role. So it's sort of providing benefits in a lot of areas. I think we'll actually come on to one of those. We've got a slide on one of those students later. But yeah, that's really good, Colin. Thanks for
yeah, thanks, Colin.
No problem. Yeah, it's just showing benefits all the way, and as I say, it makes you think about problems in a different way, which is perhaps what I really meant to say, which is very useful.
Yeah. Oh, great to hear. Thanks. That's good. So I'll jump on to why study with us.
Yes, please, James.
So I think one of the reasons is the sort of the breadth and pedagogy, the history of this course. We were one of the first, possibly the first MSc course in electrical power systems that came out of the University of Manchester back in 1963. And since then we've had a a rather impressive group come through, both in terms of research and the students who've gone on to a number of different areas around the world. There's also a very wide group of academics who work in a number of different fields who've had input into the course as well. And as we've got a quote here from Stephanie, who works at the MOD, saying, "You learn something over the weekend and take it into work on Monday and sort of put it into practice." That's a real benefit that I think, Colin, you were saying. You could take a year out, study, and then come back, but actually there is benefit to doing both and jumping back and forth. It's certainly not easy. It's going to be a fairly busy time, but there's benefits to it. So this flexibility, this allowing you to study in your own time, giving you access to the materials online, certainly makes that a lot easier.
Yeah, and just a note on that, James, there's never usually a good time to start your study, but it's something you just have to leap into. Everybody who's listening to this, it will be a challenge juggling your personal life with your study and your working life, but the reward at the end is not just the qualification, it's expanding on your knowledge and giving you that edge over some of your peers who may not have been on such an academic course.
Yeah, thanks. Yeah, I'd agree with that. There's no good time to do it, so you might as well jump in if you think this is something you want to do. Another reason that, and a lot of people are interested in when they apply, is thinking about their chartership. So we are accredited for further learning with the IET, so the MSc is accredited for that purpose. And we've been linking with the IET to talk about how we can help that journey for people coming on to get their accreditation. It's something that a lot of people have been interested in. And I think depending on where you work can help your career progression and gives that sort of mark of respect and standard.
Yeah, chartered engineer membership is quite important from establishing yourself at a certain level. I think it opens doors for you, and it's also recognition of the work you've put in. And obviously, the MSc is one key element of becoming chartered, like you said. So it's quite important in my view.
Yeah, I think there's a requirement that you have to show that you're at the master's level through something, and I guess going into an accredited course is a very obvious way of ticking that requirement. The other thing that I wanted to point out is that we've got quite a broad and diverse academic team. So you won't necessarily be taught by all of them, but lots of different academics from within Manchester have inputted into this. So some of them are, obviously a large proportion are electrical engineers, but some focus more on devices, some focus on future systems, some focus on economics, some focus on sort of degradation of oils and equipment, transformer equipment, and how that behaves once you've got a piece of kit in situ for decades. So that's almost a chemistry and material science piece. And there are a couple of people who are focused on the physics of insulators and conductors and looking into those. So it's nice to be able to have quite a broad group to input onto this and to hear the perspectives on. And certainly if you're looking to do dissertations, we've had people say, well, actually we didn't go into it in maybe as much depth as we could, but they wanted to do a piece of research in insulator design in a particular application. And we have an academic whose research area is very much that. And they were able to pick a topic that was quite specific to what they wanted to do, which is nice. It's nice having a big team of experts in those areas. And I think one of the other big benefits is actually your cohort, the other students that are there. we've had people from obviously a lot of the large kind of international engineering firms, someone like a Siemens, a number of different system operators, transmission system owners, or distribution network owners from around the world. We've had people from consultancies, people working in particular device manufacturing. And it's nice to hear the conversations that happen between students. We had one a little while ago where a student who was designing a particular piece of kit and another student on the same unit was installing that piece of kit. And they were having a discussion about, well, actually, what did you mean by that? How could we, because they were trying to do something slightly different that wasn't necessarily, it should theoretically work, and there was a little bit of back and forth. We've also had some nice discussions with people doing the same role in different countries. And that's one of the things so I teach one of the very first units. I try and bring out that discussion to say, well, you two are doing the same role. How is it different? And so one of my, the first questions I ask is, what's the load profile across a day or across a year? And you'll get completely different answers from people going, oh, well, we don't really have seasons. We don't have an air conditioning load. We have a heating load. We have a lot of heavy aluminium kind of industry. We have a lot of manufacturing, we don't have that manufacturing sector in the same way. Ours is a service sector. Completely changes what you'd expect to see in terms of the demand across a day or across seasons. So in terms of the practicalities of what the course looks like, there are 8 taught units, each lasting a fixed period of 10 weeks. Now, 4 of those are coursework based, so you'll be often given access to a piece of software, you'll run some simulations, and you'll do some coursework around that. And then 4 of those are more traditional exam based. You'll do some calculations and maybe like more what you'd expect a university exam course to look like. Once you've finished all of those units, you move on to the dissertation project. And as I said, we want this to be ideally linked to something you're doing within your job, you've got some experience in, and you can, that really benefits you and forms that link between industry and academia. So those 8 units, we run 4 blocks a year. So you can take 4 of those in a year. So 2 years to complete the taught period is the minimum. For the dissertation, the shortest you could realistically do it is 6 months. And that's happened. We've recently had a graduate who's graduated in 2.5 years. We do allow a year for that. And actually we say sort of up to 5 years, because a number of people will say, I need some flexibility, I need some time here. So they'll only study 2 or 3 units in a particular year because maybe there's a big project deadline, maybe they're going away on holiday for a long period of time, or maybe they've got personal reasons, which means they don't want to take on the full 4 blocks. So you just let your course advisor know and we'll come up with something that works for you. And in terms of what we actually teach, the first unit is more getting a recap and getting people used to what we're trying to do, and master's level study. Then we'll start analyzing power flow and component analysis. We'll move back into talking about the physical kit, what's in a substation, how do you look after that over the decades that it will be there. Then we think back more to the system level. How do you optimally run and design a system? Then we'll look at future trends, future changes in smart grids unit, thinking about what's next. And that unit is a lot of your own research, trying to look at a particular aspect of, maybe it could be integration of electric vehicles, maybe it could be demand side management. Then we move into looking at dynamics and quality of supply and how do you protect these systems, before finally moving on to techniques for research and industry, where that's a team project where you're to look into a particular innovation or to propose an innovation project, write a short business plan and sort of pitch it to me to say, this is a project that I think should be done. So you're doing a lot of your own research. It builds you up as a prep. to both think about the driving change within your industry and innovation within your industry, but also prepping the individual research to lead you towards your dissertation. So that's a very quick tour of what gets taught. In terms of the specifics then, there are a lot of the material is online that you can study in your own time. In fact, there's very little that you have to be there for a particular time for. So there are recorded videos like the one you can see here, where I think you're trying to work out how many electric vehicles would this system actually cope with. You're trying to look, then you've got access to a lot of online textbooks, and there'll be recommended reading from that, or you get access to IEEE Explore and a number of academic journals, and we'll link you into those. There'll be discussion activities, there'll be practice problems. Then there's the live sessions, so we will run video tutorials, interactive video kind of Q&As, where you can ask us questions. Obviously, you'll be assigned a tutor, and you can email and ask for support that way. And there's a lot of kind of practice exercises where you'll show you're working through that. We also give you access to a number of different pieces of software. So at the moment, I think the software we use on the course is IPSA, PSCAD, PowerWorld, and MATLAB off the top of my head. But there'll be different pieces of software for the different courseworks and projects we run. So to get onto the course, what you'll require is a first or upper second class honours degree in something relevant like electrical engineering. And then we'll start looking into your grades in the relevant units within that. So we'll need to see your transcript. We'll be particularly looking at the electrical side, any units in power systems, protection, high voltage, and the maths. It's quite a maths heavy course. There's quite a lot of calculations involved here. So we'll be looking for a good grade in those as well, factoring in the standing of the institution. There is a slightly different entry route if you are narrowly off those. Obviously, you still need to be able to do the course. You need to have that certain level of maths and certain background knowledge of power systems, and be able to evidence that. But if you're not sure at all, if you contact the Study Online email address, we'll be able to get back to you and talk you through whether you think it's worth putting in an application. There's obviously evidence of English competency and the fees as well. But for any questions around that, just post an email in the Q&A now, or send something on Study Online, and we'll be able to give you more details. And yeah, so there's been some great quotes from our students. So Victoria works as a system engineer in Uganda, and she was saying it's really nice to be able to link up with taking the knowledge from the course, from the other students, from the things she learns, and pass it back into the area she works. And actually, David was doing a similar sort of thing. So he works for Scottish and Southern as a protection engineer, and his dissertation was the one that I thought really explored a topic that he was working on with a problem he needed to solve. And he did a really excellent job at not only finding a solution that was very academically rigorous, but was very practical to the job he was doing day to day, and just got an absolutely fantastic outcome from that. And I was really pleased with both of these students actually, and how well they'd done.
Wonderful, thank you, James. Thank you, Colin. So that's the end of the presentation today. We do want to hear from you. I can see we've had some questions come through already on the Q&A. Just to reiterate very quickly, I know we touched on, as the entry requirements earlier, but just to reiterate what James said, if you are interested in applying for the course, we're accepting applications. It's a popular course, but our September intake, September 2021, we are now accepting applications from students. To ensure, I suppose, a smoothest journey for yourselves, and please do, if you are interested in studying with us, please send through your CV and, as James said, a copy of your degree transcripts to study online at manchester.ac.uk, and then I can we speak with you, we can have a chat and talk through any questions you have, but also to work out what's going to be the best entry route for you as well. So the transcripts and your CV and your degree certificates will all be required anyway if you do submit a formal application. So if you could send them to me before you go through that process, we do find it's extremely beneficial for students, and as I say, it can also smooth the actual application process for you as well. Colin, just out of interest, when we mentioned before about some of the students working for National Grid, have they said anything in regards to how they found managing studying the course and working full time? Have they sort of come to you with any interesting points?
Well, it is quite interesting. Most of them managed okay, and I don't want to put anybody off because it is really a worthwhile thing to do. But there's an added element with a lot of the students I deal with in National Grid. I say a lot, a number of them are shift workers. So you've got the elements on top of the fact that they're working on social hours, then trying to get to be disciplined enough to do your learning is quite tricky. But again, it's like I said before, there is never a perfect time. And I would urge anybody who's thinking of doing it not to put blocks in themselves. It will be challenging, but actually it will be worthwhile in the end when you've completed it and you've passed. So yeah, I've had a few issues with students, but you guys have been pretty good. You've been helpful and flexible where you could be. So I haven't come across a problem that we haven't been able to solve yet. There's always a first time for everything, but we've been.
Don't say that, Colin. There's no problems that we can't solve. No, that's wonderful. It's always good to get, a perspective from someone, like I said, in your position. Obviously, you're working with the students, they're all working full time. But as I said, that flexibility is important, which is why I suppose the online course is so appealing to those in the industry. We have actually had a question come through. I know we sort of touched on it earlier, James, just in regards to someone's asked, how long will it take to complete the course? I know we did sort of touch on that, but I know it's sometimes a bit blurred, isn't it? People never know.
Yeah, okay. So the minimum is 2.5 years. 3 is probably the time that many people could complete it, but the flexibility is there so that if you want to take longer, you want to take breaks, then you can complete it in up to 5 years. So the longer period is just there if you need it.
I think the thing I've found with students is if the dissertation is the big piece of work that they sometimes struggle with, and that's where I said if you can align it with something either you're doing yourself or certainly that somebody you work with is doing, it makes it a lot easier, and it gives you much more rich subject area. That's not to say if you want to do something, provided it fits with the guys at Manchester, something that's completely off a subject area you work in, that's good as well as a way of expanding your own knowledge. But we certainly found that working with something well is quite helpful in terms of speed if you want to complete fairly quickly.
Yeah, I'd say that's true. We have had students use it as an opportunity to learn an area they'd always wanted to really go into depth on it, and that's fine. It just might take you a bit longer, more like a year than if you really wanted to push through quickly on the dissertation side.
Wonderful, thanks. Thank you, Colin. Thank you, James. We've had a question just through as well from one of our prospective students. Says, I have a bachelor's degree in electronics and communication engineering in 2004 from India. I've been working in the UK from 2005 in various technical roles like telecommunication engineer, project engineer and project manager within the oil and gas industry and in highways. Will this course help me get my chartership, and also would I need to have an electrical engineering background to do the course?
Yeah, so we do have a few people who apply with something like electronics and communication. The problem is I can't really answer it unless I can see the transcript, because some courses will have very little that's relevant to this course. Some will be, you've picked a few options in electronics and communication, but there's a broader base of electrical engineering. It also depends on what specific roles you've been doing in oil and gas. I know there's a lot of power systems roles within that area that would add some skill and some knowledge that would be relevant to your application. So when you're applying, if you highlight those areas and highlight what you've done that you think would be relevant to the units we've talked about and the course more generally, that would be really useful. So you don't have to have electrical engineering as your degree title, as long as you've got that prerequisite knowledge. And I think you can do well on the course. I'm happy, and certainly worth applying.
Yeah, absolutely. Thanks, James. So yeah, if you would like to send through your CV and your transcripts, as I just sent it to study online at manchester.ac.uk, and we can have a look through that and obviously provide you with further guidance. I had another question as well from another student I've spoken with before. So hello, Lowell, nice to see you've joined us today. Just in regards to his IELTS, and if that's required, what I'll do, Lowell, I can actually speak with you direct about that, because I know I've got all the information required with that. So it might be that you don't need to do it, because I know you are based in the UK, so I can cover that one. I know I've got lots of questions coming through thick and fast, so we might not get through them all today. So if we don't answer your question, please just email it through to me, and I'll have a look at it after the event. But just another quick question with regards to the units. Someone's just asked, how are these assessed?
Yeah, so in normal times, what we do is we'd normally partner with a British council or a local university, so that you could go and physically do the exams, the 4 exams across the taught units there. Obviously, at the moment, no one is doing in-person exams, even for the students who are based within Manchester, so everything is online. So what we're doing, or what we did for the last set of exams, was you'd get access to an exam paper with a timed window. You'd submit everything as photographs or scans of each of the images there, and that would be marked. There was also some other elements, but for half of it, it's all coursework based and all online anyway. There are 4 exams that will either be online or will be in a local British council. And if you're worried about being able to get to one of those, again, if you contact the Study Online at Manchester, we can let you know the sites that we use for that.
Absolutely, we can. So I think that's all we've got time for today, but I'd just like to say a massive thank you to James for joining us, James Brooks, but also to Colin. Colin, thank you so much for taking the time out. I know you're a busy man, and it's been a bit sort of can go whether you'd make it today, but it's been absolutely brilliant to have your insight, as I said, from an outside perspective as well.
No, thank you, Lisa. Thank you for the opportunity as well. It's just probably one of those things we probably wish we had a bit more time.
It is. It's always one of those. I know when I'm speaking with James, that how much time do we have for this?
Yeah. Well, I do see there's other questions popping up, and I think maybe we'll get back to these people by email. I think is probably the best way now, because we are running beyond the time that we said.
Absolutely.
But yeah, we'll get back to you if you've just sent an email through.
Yeah, send everything through. I'll pick them up. As I said, we are accepting applications for September 2021. So any questions with regards to any elements of the course or some of the points we can see now in the chat function, just send it through to myself, and I'll pick those up for you. And yeah, we'll go through them then. But thank you so much to all our viewers. And if you're watching back again, thank you for joining us. But again, a special thank you to James and Colin.
Thank you.
Thank you.
Thank you.